To introduce this section, let's look at an example here to see what we might be getting ourselves involved with. Let's look at the square root of x equals 9. Well, what do we know x to be in that case? Well, we know that x was going to equal 81. And we can check that. The square root of 81 equals 9. So we know that we have a solution of x equaling 81 in that particular case. Now let me add a different example to you. Let's say that we start with some x equals 4. And let's say I want to square both sides. So this becomes x squared equals 16. Do you remember how we solve a potential quadratic here, or potential term with x squareds? Well, we said equals 0, so x squared minus 16 equals 0. This is a difference of two squares, so that factors down to an x minus a 4 and an x plus a 4. And my solutions to that is either x equals 4 or x equals negative 4. But notice that this original equation just started with an x equals 4. Yet, as I went through our process, I was able to produce two answers, a 4 and a negative 4. So the take home here is when we're dealing with solving radical equations, specifically when we're raising equations to an even root, we may get another solution. It's called an extraneous solution. They may not be a solution at all. So we always need to check our solutions because we may have introduced what we call an extraneous solution by this process. Now, I want you to kind of think about that a couple of times, rewatch this so you get that sense of where that extra one came from, and do that enough so when we look at solving problems, you're going to remind yourself, got to keep doing that. All right, so what's my overall process for solving radical equations? Well, the first thing we want to do, if necessary, let's rearrange terms. So we have all of our square roots on one side, all of our other terms on the other side. So arrange, isolate the radicals. Step 2 that we typically want to do is raise both sides to the appropriate exponent. Step 3, we want to go ahead and solve that equation so that the root disappears or that x is by itself. If that's not the case, sometimes you're going to need to go back and repeat steps 1 and 2. And typically our last step is check the solutions, because we may have introduced an extraneous solution. So we're going to check our solutions back on the original equation to find out if they both work. And if one doesn't work or both don't work, we scratch them out. So we'll go through this process in a couple of examples to help clear up the mud that I just kind of stirred up in your life.